So, all right, we can start with today's session. So, as mentioned, today's session is going to be a short session on DEA. So, before getting into the technical part, we'll have a quick revision of DEA. So, can someone tell me what is DEA? And don't tell me it is data envelopment analysis. We can have better discussions. What is DEA? What is your understanding about DEA? Anybody wants to try? There is no penalty for wrong answers.
It is data envelopmental analysis, and where we maximize our when we
Efficiency.
plot this.
Efficiency.
Yes,
Okay. So
yes.
we'll take it step by step. Since we have less number of people, so we can spend more time on understanding DEA. So first of all, DEA focuses on maximizing efficiency. So what efficiency does it maximizes? It's called productive efficiency or production efficiency. So we are trying to maximize the output under given constraints. So the output here is nothing but efficiency. So what is the formula for efficiency in DEA here?
Weighted output divided by weighted input.
Oh, great. So I was looking for that weighted thing. And how do you select the weights here in a data envelopment analysis problem?
By optimization.
Super. What kind of optimization it is?
It's finding the maximum.
Maximum. So it is a linear optimization.
Yeah.
But just now one gentleman told me that we are trying to maximize weighted output by weighted input. So when you have ratios, it is non-linear. How are we linearizing this problem?
By normalizing the denominator.
Normalizing the denominator, and we are making sure through our constraints that efficiency of no DMUs. What is DMU here?
Decision-making unit.
Yeah. So by normalizing the denominator and by setting constraints, we make sure that no DMU gets an efficiency of greater than 1. So you also have some something called productive efficiency frontiers. What are these efficiency frontiers?
They have the maximum efficiency.
Hello, sir. Cannot visible. Your screen is not visible to us.
No. I'm not sharing my screen. I'm just having a discussion about data envelopment analysis. We'll do screen sharing and do some problems. All right. What else did you?
Yes.
What else did we cover in data envelopment analysis? What is the understanding? So these are all theory stuff. Can we take some example and understand DEA a little better? Sure. So let me open Excel. Right. So is my screen visible? Sorry, if you give thumbs up, I can't see.
Yes, sir. Now it is visible.
Got it. So let us take two batsmen, batsman 1 and batsman 2, right? So Malolan is very good with writing. Since my handwriting is so bad, I prefer doing it on Excel or PowerPoint, right? So if you want to compare two batsmen, it could be Virat Kohli, Sachin Tendulkar, or it could be classical test batsmen like Steven Smith and Brian Lara and so on, right? So these two people they are different people. They are not the same people. So Steven Smith is playing in this generation. So in this generation, it has all sophisticated technology where you could assess the bowler. You have this DRS and so on. Whereas Brian Lara, he played in the past where there were no field restrictions and it was a tougher time. So if you want to compare two batsmen, how do you do it? What are the inputs that you can think about? What are the inputs that you can think when comparing two batsmen? Can we say number of matches played? What could be the other input? Number of deliveries faced. What could be the output? This is simple. What could be the outputs? Number of runs, total number of runs. What else? Can you think of some
Strike rate,
strike rate?
average.
Average. Can we take average? Okay. I'll take. Let us keep it simple. We'll take only 2 inputs and 2 outputs. But this 2 input, 2 output is just to give you an understanding. But if you want to do this on a real-time data, especially when you want to try this out in industry, you will have some hundreds of inputs and you will have some 30, 40 outputs. But DA is still doable, right? So these 2 inputs, 1 output, and all these things are just to give you an intuitive understanding of what DA is all about. So now, what is X11? X11 is nothing but, this is your first feature, this is your second feature of the input, this is first output, this is second output. So this one here, X11, so X11 refers to the first input of the first batsman. X22, X21 refers to the second output of the first batsman. Similarly, you have X21 and X22. So this is for input variables. This is how you define your decision variables. Next comes Y11, Y21, Y. Sorry, this is 1, 2, 1, 2, 2. This is 2, 1. This is Y22. So these are the features. So for each feature, we are going to give weights. So you will have A11, A12, A21, A22, B11, B12, B21, and B22. So in DA, what are we trying to maximize? We are trying to maximize the efficiency, which is nothing but weighted output by weighted input. So these weights that are associated with inputs and outputs are going to be your decision variables. So you are going to change your weights so that efficiency of batsman 1 is maximized. So first we'll try to look at the efficiency of batsman 1. So you form the objective function, you give the constraints so that batsman 1 is going to maximize his or her efficiency, right? So when the efficiency of batsman 1 is 1, you say that this particular batsman 1 is efficient on his own inputs and outputs. So next, what are you going to do? With the metrics of the weights of batsman 1, you are going to compute the relative efficiency of batsman 2. And if the batsman 2's efficiency also comes to be 1, he is also efficient in relative to the first batsman, right? And similarly, you repeat the procedure for batsman 2. First, you find the efficiency of batsman 2 for his or her own inputs and set of outputs. And then with that weights, you assess batsman 1. So this is how data envelopment analysis should be done. So any doubts here?
Sir, cannot understand the process.
Okay. What process? So first of all, you have only 2 batsmen, batsman 1, batsman 2. You can have batsman 3, batsman 4, and so on.
Yes.
Right? So first of all, you are going to solve for batsman 1.
So here we are looking for multiple inputs and multiple outputs.
Yes. So these are multiple your inputs. So I have given
Yes.
an example of 2 inputs
Yes,
and
yes,
2 outputs.
yes.
For each input, there is going to be a weight. For each
Right.
output, there is going to be a weight. And
Yes.
for batsman,
X1, Y1 is the input set of input for batsman 1.
so that's why we have 2 prefix. So X11 refers to the first input of the first batsman, which is number of matches of batsman 1. Similarly, X12 refers to the second input of the first batsman.
It will appear in this type of alphanumeric, or there is a numerical value. Actually,
You will have, see, what is the number of matches. So one batsman 1 could have played, let us say, 100 matches.
yes.
Batsman 2, and he might have scored, say, 2,800 runs. This is batsman 1. And batsman 1 could have faced, say, some 4,000 deliveries. And the average would be 50. This is for batsman 1. So your X11 will be 100. Your Y11 would be 28,000.
Yes, yes.
This is how you write your decision variables.
Okay.
Right? It has a numeric value.
And X21, X22?
You will have
Another set of input and output.
Yes, for the second batsman. This is for first batsman. Similarly, you will have something for the second batsman, third batsman, fourth batsman, and so on. And the process that I repeated is, first you calculate the efficiency of batsman 1. And for whatever weights you have got for batsman 1, you take the same weights, and then for this weights, you are assessing batsman 2. Is batsman 2 relatively efficient with respect to batsman 1? That is what you are trying to compute. If his efficiency is coming to be 1, then batsman 2 is relatively efficient.
May I ask one question here?
Yes.
How do you calculate the weight?
That's what your linear programming is going to do. Your
Okay.
linear programming is going to give you the set of optimal weights pertaining to that particular decision-making unit. It could be batsman, it could be machine, it could be human beings, organizations, and so on. Okay. So I see a lot of people talking about a particular problem in your assignment, right? How many of you find this problem slightly difficult? Has anyone solved this particular problem? So these are some of the numericals from data envelopment analysis. So for the interest of everybody, can I read this question? It may not be visible. The font is not that great. Okay. So here there are 6 business units. We could also have a discussion about DEO with respect to this particular question. So there are 6 business units or 6 decision-making units. And for these DMUs, we have got 2 outputs and 1 input. So the other combination that we have discussed in the lecture is 2 inputs and 1 output. But this is slightly different. 2 outputs and 1 input. Right? So well, let's discuss about this first. So 2 outputs and 1 input. You are solving an optimization problem for business unit 3. And you find that the efficiency is 0.7. And you find the dual variables corresponding to constraints of business units 4 and 5 to be non-zero. What does this mean? 4 and 5? The dual variables corresponding are non-zero. What does this mean?
That means it's applicable. Those constraints are in play.
Playing this.
What is the physical meaning of that?
Oh yeah, Malo, hi.
Hey man. Yeah, to show that I'm here also, I'm asking questions. Yeah. What is the physical meaning of a dual variable? We discussed it last time, no?
So, sorry, sir, is this a previous term question paper?
No, this is your practice assignment.
Which week?
9th week. because I also saw a person posting this question on Discourse. So therefore, I chose to discuss that now.
What is the physical meaning of a dual variable? Dual price. Okay, why? What did I say last time? If a constraint is binding, then the dual variable will be what value? I made a mistake, then I corrected it.
Constraint is binding, then it is non-zero.
It is non-zero. So what does that mean?
There is a limit that the constraint.
So it is non-zero means the dual variable basically tells you the worth of resource to you, right? So this when I say a constraint is binding, and then if dual variable becomes non-zero, then that is a worthful resource for me.
As in a contribution it is making?
Yes, I can invest in that to increase my increase my
Right.
profit or decrease my cost, whatever, based on the objective. So there will be an impact, a positive or a negative impact, by investing in that particular resource. So that is the meaning of a dual variable being non-zero. So now coming to the Swami, over to you. So now coming to this.
Yeah. So one thing is clear that you have not watched the videos of DEA. So we have one more live session. Yeah. Have you watched? Have you all watched?
Yeah, I did.
Okay. So then it will be relatively easy. If you had watched, this discussion is going to be slightly more interesting. Else it is going to be slightly difficult. So here, if you say the dual variables corresponding to business units 4 and 5 are non-zero, it means the shadow prices of 4 and 5 are non-zero, which also means for the business unit 3, your reference DMUs are nothing but 4 and 5. So if you remember the lecture video, if you want to make an inefficient DMU efficient, you have to move towards a particular line, right? So that line is nothing but somewhere between this DMU 4 and DMU 5. So these are called reference units for this particular business unit 3. Why? Because this DMU 3 or business unit 3 is inefficient. The efficiency is only 0.7. And if you want to create a HCU, by the way, what is HCU? Anybody wants to try HCU?
Hypothetical composite unit.
Okay, so we'll break it down. What is hypothetical here? Why it is called hypothetical?
Because it is not really a point. We are trying to optimize the point to that line.
Yeah, so very well said. So it is a hypothetical point which is actually not present, but if there is a point that is lying somewhere, it is going to be more efficient. So that's why it is hypothetical in nature. Why composite?
Because it is taking into play multiple non-zero shadow variables.
Yes. So here we have two. Generally, it will be two. So you are going to find that HCU, which is going to lie somewhere between 4 and 5. So it is derived out of business units 4 and 5. So therefore, it is hypothetical composite unit. And these dual variables corresponding to the constraints. Okay. So other dual variables corresponding to the constraints are 0. So only these two are non-zero. So how do you, okay, let me read this question fully. So the dual variables corresponding to the constraints of business unit 4 and 5 are 0.3 and 0.4. Right? You are given the following table where sales and number of leads are the two outputs. Generally, how do you do it? How do you calculate the sales in HCU3? Can someone try?
Uh, 0.4 into 10,000 plus 0.3 into.
Is my screen visible, sir?
Yes, it is.
Okay. So we have, okay, first of all, let me write down something here. So your efficiency of business unit P is 0.7. And your dual variables corresponding to business units 4 and 5 are 0.3 and 0.4. 0.4. Now you have sales as a input and sales as an output, where you have 10,000 and 8,000. Right? So if you want to find the HCU, how do you do it?
0.3 to 10,000 plus 0.4 into 8,000.
Okay, so let's check if it's working out. 0.4 into 8,000. So your answer should be 6,200, right?
Yeah.
But look at this answer. Your answer is not 6,200, it is something different.
Oh.
Why is it so? I'll give you a clue here.
0.4 respectively.
It is because of these two dual variables, 0.3 and 0.4. Because of these two dual variables, your answer is not 6,200, it is something different.
Sir, we will do 6,200 upon 0.7.
6,200
upon 0.7.
0.7. Wow. Nice. But the actual way to do this is fine. If you add up your efficiency of the reference DMUs, it is going to match your efficiency. 0.3 plus 0.4 is nothing but 0.7. So the ideal way to do this is normalize your DMU, respective DMU's efficiency. It is going to be 0.3 divided by 0.7. Second, 0.4 divided by 0.7. So now if you use these two as your dual variables, these are actually not your dual variables. These are the normalized dual variables for DMUs 4 and 5. So here if you do that, 0.4 into 10,000, this is nothing but 0.57 into 8,000. Then to do an auto sum, it's going to be 8857.143. So the sanity check for you people is that generally, if you add the shadow prices for a DA problem, it should add up to 1. If it is not adding up to 1, then you will divide the efficiency that is given in the problem divided by the efficiency of the business unit that is of interest to us and normalize it. And now if you add this, it will be 1. If you add these two, it is going to be 1. Whereas if you add these two, it is going to be the efficiency of the business unit of our choice. So the best way to do this is check for these variables. Are they check for the shadow prices of the reference DMUs? Are they adding up to 1? If they are not adding up to 1, normalize them.
One question. Do they always add up to certain value, like in this case 0.3 plus 0.4 is equal to 0.7, or it can be this is 0.3, 0.4 and the overall efficiency is 0.8 or 0.71 or something like that, not equal to 0.7?
There are cases where it doesn't add up, but you can safely assume that it is going to add up to the efficiency.
Okay. For the purpose of this course, it will always add up.
Yes, but
okay.
This is a special type of problem, right? You look at this problem, you are getting 2 outputs and 1 input. So
Right.
generally, in the other scenario that was discussed in the lecture, where we have 2 inputs and 1 output, your shadow prices will eventually add up to 1. If it is adding up to 1, you don't have to normalize it. If it is not adding up to 1, divide it by the efficiency of the business unit. That is of interest to us. Here it is business unit 3, and the efficiency is 0.7.
Normally speaking, how does it hurt to keep normalizing as a process procedure itself? That way we will not miss it, right? Even
Yes.
if by 1 it is okay, doesn't matter.
Yeah, you can do that.
Okay.
Yes. So these are some of the things that I wanted to discuss. And generally, if you want to prepare DEA for your final length term, the only kind of numerical that is possible is these things. Have a good understanding of the intuition behind DEA. So where are we going to use DEA? What are we going to identify? How are we comparing efficiencies of 2 DMUs?
Sir, which was the syllabus of end-term exam for BA?
Everything, sir, whatever you have learned.
1 to 12.
12, the week 12 is generally an epilogue where professor must have summarized the entire contents that you have gone through in this.
When, sir? When there will be a revision session?
Revision session. Malalan, do we need a revision session?
They have been doing it every week, man. What do you expect in revision session, to be very honest? I do not know.
Summary.
Because sir, most of the session is not recorded, no? That's why.
Most of the session is not recorded. Pardon me, only 2 sessions were
Not recorded.
one session was not recorded. Only the discussion on quiz was not recorded.
No, sir. Previous 2 session is also
No,
not
it was
recorded.
recorded. The recording, I do not know where it's available. I've already given it to this thing. Only one session, which was the discussion on the quiz, was not recorded.
If we get, then we will. Okay. If we will get, then we will.
So far,
yeah.
Sir, 1 to 8,
Okay.
there will be a 40% weightage or 60%. Is
We
there any
do not have.
is there any strategy that?
No. We don't have any such strategy. We give almost equal importance to everything. No matter how much you try, I do not know, man, what to tell you.
So we can do one thing. So this week we have discussed DEA. So next week we'll discuss conjoint analysis. Okay. So I request everybody to watch.
Sir, one question, if I can ask.
Yeah.
Sir, I was
Please.
telling about that we will divide by 0.7. The business unit 3 has the efficiency 0.7, right?
Yeah.
So that's not the right. It will go about it.
It was. You are doing the normalization later, that's all.
No.
You are
Sir,
doing the
why is it
normalization
normalization
numerically speaking.
Particularly, and then after adding it.
See, denominator has a 0.7. I did not put it at the beginning. You put it towards the end. That's about it. You can put it wherever you want.
So, but if I ask you what is the normalized dual variables pertaining to the reference variables, you will have to do it again.
Yeah. Correct. Yeah.
Is there a possibility of those questions also? Just
bro.
Okay, since
So
So since you guys are asking a lot of questions here, I'll give you this hint for all those who have come for this video, for this live session. DEA questions are going to be hard in your exam.
Yeah.
So prepare well for the DEA units.
oh boy.
DEA question.
That's one hint. Questions domain. Yeah,
Okay.
questions DEA.
Yeah.
Questions in the weeks of basically 8 and 9, right? Yeah, 8 and 9 is DEA.
Okay.
So questions in the weeks of 8 and 9. And that too, Swami has made it hard, not me. Swami has made it hard.
Okay. Then
Can you provide some practice questions, some more practice questions?
Exactly. Please.
Oh,
Okay.
Last week you mentioned about this book by Professor Srinivasan.
mhm.
Checked out, it is not available in print.
Okay.
I ended up paying to PHI also, and now they are not refunding me my money. The book is also not available. Is there some other source, please?
Not available.
They said hard copy is not there, and the website advertised that was there. Amazon, Flipkart, it was not there. PHA was showing it was available, made the payment, and then 3 days later they sent a message saying the book is out of print and The money is not coming back. Money is not coming back in the sense they wanted my bank details and all that. I just told them to reverse the transaction, which is a credit card transaction. They are not done anything about it.
Oh my God.
So nobody, please go to PHI.
Okay.
Pintai Silent here, please don't go.
Okay, I will also inform this to Professor
No.
Srinivasan.
Yeah.
So as far as DA is concerned, problems are going to be similar. So for whatever we have discussed now, whatever is covered in the lecture.
No, but little bit more problem. If Malolan sir is saying hard, it means it's really.
No, bro.
Hey, okay. Do one thing. Take the previous year question papers. Do some effort, man. Take the previous year question papers. You will have a lot of problems.
We are giving our best effort in BA course only.
Oh my God. Okay.
No, the problem is every
MLT
term.
we are handling pretty well, but BA is going to be really hard.
If anybody has the previous year question, please share it in the WhatsApp group.
So
Every term the question paper gets a little more trickier. So
Exactly, the pattern is never been.
if it is the same tricky level, then it's okay, but it gets trickier. So practice is a better idea.
So the expectation from you people are way too high, the students. So in the industry, when they say that you're coming from IIT, right, and if you appear for interviews, the expectation they have with you is way too high. And for that expectation, the standard of question paper that we are setting is not even 50% close.
No, that's not what I'm saying.
But
Sorry.
at least we should have practiced.
There's a misunderstanding. I'm not worried about the question paper being tough. It is about not having enough practice to face that level of questions is what I'm actually talking about.
I get it. So I give you 1 or 2 questions for DA. That's not a problem.
Yeah.
Second, I gave you practice problems. So I gave you red brand canners. I gave you the assumptions for linear regression. But I got no questions on discourse pertaining to those extra materials.
Sorry, I missed a few sessions. Can you tell me where these questions, the material that you saved are?
No, this was sent to you by email. So there was a request for giving more problems for linear programming formulations and so on. So therefore, I gave a classical case study, which is called red brand canners.
Yeah, it came by this thing. It came as an announcement email with all the links.
Yes, attachments.
Let me just pull up the date for a second.
It says additional resources.
Yes, additional readings and so on.
Okay, so we have not seen.
But when was it sent?
Yeah, I'm just trying to pull up the
additional resources. Yes, it was sent on 10th of August.
Yeah.
Red brand canners. Okay.
So try to do these formulations. This will help you. This is, I mean, that is no way related to your exam. Those are additional reads. But once you are done with BA, if you want to continue learning BA, please look into those things. It will be really helpful.
And regarding your practice assignments, when you say you should not expect questions as practice assignments, your assignment questions itself, when you start solving by hand a bit, let's say create the table and then solve by hand, that itself is a practice for you. So that is how this course works, basically. The end term, we will have to ask you some limited type of questions, so we are giving you such questions, but that is how it works. I believe you are too much used to a regular course that you do not see the difference here. This difference is like coming like a shock. That is all. And to be very honest with you, unlike your previous batches, they didn't even get a Mark 1 or Mark 2 for quizzes. We asked them to use this thing and the previous questions. But for you guys, we have compiled all the previous important, let's say, difficult questions for the previous question papers and given it to you as Mark. So that help and all we have done. It's not that we have not, but yeah, after a certain point, you should start to develop questions and start to solve them on your own. That is the expectation.
We'll do one more thing. Next week, we'll again meet. We'll discuss a little bit of conjoint analysis and then prepare and come if you have some questions, right? So let's discuss them and we'll close it in the next week.
Okay.
So any more questions on DEA?
Yes, sir.
DEA, Yeah, please go ahead.
So that it's more of what DA do. I mean, DA is used, for example, if I have a company and which has 5 branches, and if I want to close one of the branches, so DA will give me idea like which is the least efficient one, and I can close it. Or if I want to improve it, what can I do to improve it? This is what DA do.
Yes. Last week we discussed about predictive and prescriptive analytics. So DA is one such technique. It's called prescriptive analytics. What kind of prescriptions you are making? Can somebody talk about that? What prescription are we giving here? From DA, what are we prescribing to DMUs? So here, yeah, please go ahead, Ravi.
No, when you say prescribe, you are asking what we are going to come to as a conclusion?
You are going to recommend something. What is
Based
that?
on one unit, I rate the other units. Assuming
Okay.
this unit is, I think what I understood is
How
give
to
the weights.
yeah, please continue.
You have the unit, you rate the unit, and if it is 100%, then you rate the other units against this.
Okay.
And you see how the others are faring against this one. Is that about right?
Okay, what if this particular unit that is of interest to you itself is not efficient?
Yeah, this I remember reading that it will also come out whether it was or not.
Okay, so Abhijit
Kalpita
had a point.
Yeah. So it is recommending the companies how to optimally use your resources to give the best output.
Okay. Okay. To an extent, yes. But what is the main purpose of what is the main prescription that DA is doing?
To reach the efficient frontier.
Oh yes. If you are an inefficient DMU,
what
how do you convert an inefficient DMU into an efficient DMU? That is what DMU is. That is what DEA is prescribing. Either you have to cut down on your resources or you have to increase your output. In the example that is discussed in the video, professor talks about either you cut the number of people who is working on a particular office, or you increase the sales, or you increase the number of sales leads. Either you have to increase the output or you have to decrease the output. How much? By how much? That is what DEA is prescribing.
Understood, sir. So one more question. Why do I have to move both the sides? I mean, when we consider moving vertical and horizontal, why don't we consider only those things? I mean, why do I have to consider both of the? I can do it by one unit also.
You want to move towards one particular direction.
Yes, to reach the efficiency frontier.
Can be done, but so professor spoke about a particular way where he said that you will connect the reference points with the line passing from the origin. You remember?
Yes. So that is what, like, why do I have to go that way? I can do it horizontal thing and the vertical thing. Why do I have to consider both the units? This is my question.
To achieve a trade-off. So just if you do that, it is going to increase your budget. It's just a trade-off. You're just trying to find a sweet spot between two available inputs. That's all. You're not being harsh to one particular output. You're not cutting down entirely on one particular resource by focusing only on another resource. You're trying to find a sweet spot. You're trying to balance both.
So isn't this I mean, this will depend on the situation. If I have a restriction on something, like I do not have a labors, and if I want to if there is I mean that horizontal, that line from a 0,0 is asking for a more labor, and I can not do it because I can increase the money, but I cannot increase that labor thing. So that restrict me with
it's
something.
A great question. It's a great question that you've pointed out. So if you remember this particular lecture, professor might have used a particular term called without any change in technology. So another drawback with linear programming is that it assumes that your environment is static in nature. So whatever you are doing, you say that in an ideal world, if things work this way, this is the best you can achieve. So this is the recommendation that you are giving to a stakeholder. You say that when you do this, you become efficient. And when it comes to reality, the field workers, they know whether it is possible or not possible. And they will take your recommendation or prescription as a benchmark. And whatever best is possible, they will try to work it out. That is how it happens in the industry. Malolan will differ from me slightly, but it's more of a recommendation.
Got it.
Yeah.
Understood, sir.
And to be very honest with you, in case you have such a thing that you will not be able to increase your, let's say, for example, whatever you said, if you are not able to increase particular resource, what will usually happen is, since all of this is ultimately going to be dependent on a linear program at the base, you will usually put that as a binding constraint. So the dual variable associated to with will become a non-zero value. And with that, you will be able to identify that that is a critical resource for you. Right? So that's a more theoretical approach to it, but far-fetched. Since you guys are not very well versed with the entire aspects of, since we have not covered that in this course, that is a bit fast-paced, but that will be captured in those forms of analysis that you do. So it might not be of scope for you currently. Okay?
No problem. So I understood that part.
Understood.
And
Super.
sir, sir, last doubt.
But a very good question, yeah.
So last doubt, when I can show you the screenshot, I took it from the lecture.
Okay.
Can I share it? I mean, can I share my screen?
Malo, is that okay?
Sir, try. I do not know if there is permission issue, but please try.
Okay. You can tell me what it is.
Let me try, because
Yeah.
you can get the reference of what I'm talking.
Malo, you unnecessarily told DA is going to be tough, man. Now look at the energy of these people. Yeah.
This is one of the lecture.
Yeah.
So when I get the output as 0, so I do not have to consider. So let's take an example. Like this is what company at third office. This is what the output is, and this is what the what you call it? The weight of
Yes.
weight vector of the output too. So at the end, this is what it concludes, that I do not have to consider the number of lead to calculate its efficiency. To make this office a most efficient one, I do not have to consider number of lead. I mean, without taking the number of lead, I can make this office efficient. This is what it means. Can you elaborate on this part? Like what output? I understood the input part, because when you can give something, I mean, putting something, I understood it.
Very good question. Very good question. Did you listen to the example that? Can you stop sharing? Did you listen to this particular piece that we were discussing?
Which one? Sorry.
Let me show. So did you discuss? Did you join the discussion when we were talking about A11, A12, A21, A22, and all?
I joined the meeting a bit late. Sorry for that.
Okay, no problem. So here X11 is nothing but the first feature of batsman 1, and so on. Right? For each feature, there is a weight associated. So A11 is the weight associated with X11. Similarly, A12 is the weight associated with X12. So ultimately, DA is nothing but you're maximizing efficiency, which is nothing but weighted outputs divided by weighted inputs. So in the screenshot that you shared, you were trying to maximize the efficiency of DMU3. So now DMU3 is getting the optimal weights of A11, A12, A21, A22, and so on, B11, B12, and so on. so that its efficiency is maximized. So it is free to choose any weight so that its efficiency is maximized. So in that particular case, DMU3 has chosen the weight of a particular input or output to be 0 so that its efficiency is maximized. If you remember in the last lecture when Malolan was talking about something called a non-negativity constraint, which means that it could be greater than or equal to 0. That is one constraint. But in DMU, we also have another hard constraint, which says that no efficiency can go above 1. So it is okay to get weights of 0.
Swami, I got that part. I mean, how you got a 0, and I understood like what is the procedure to get 0. But I'm not able to relate to the real life. When I say the output 2 is 0, what the number of leads, what do I say to the next, I mean, management, that you don't have to consider number of leads, because something that you don't consider, I have to take it in input. Output, it does not matter what I have to consider. I have to make it. So that is what you relate me in the real life.
Beautiful, beautiful. I mean, you are making me think a lot. Okay. So are you familiar with cricket?
No. Sorry.
No.
Football is my.
Okay. But do you understand a little bit of cricket? Because everybody will understand this better. Do you know?
Do not go to the rate strike and everything. I mean,
strike rate is okay?
No, I don't know those things.
Okay, we'll see what strike rate is all about, right? So
can I explain the strike rate?
No, because it is very interesting. The question that you had asked me is very, very interesting. So let's take some outputs, right? So let us say number of matches is one output. Let us say number of runs scored. It's another output. Let us talk about average. You know what is an average. So there is nothing fancy about this, right? There is something called strike rate. Strike rate is nothing but number of runs scored divided by number of deliveries faced, right? Is it okay? Any problem with this? Anybody problem with this?
Number of delivery faced means the balls.
Yes.
Okay. So it's for a 6 balls or I mean.
No, let's say he's faced 10 balls and he scored 20 runs. So 20 by 10 into 100, that is going to be 200%.
Understood.
So his strike rate is 200%.
Okay, I understood that.
Right. So this is the strike rate. So now imagine a test match. Right? Imagine a player like Pujara or Rahane. Right? So these people, they would have played a lot of matches. Right? They would have scored a lot of runs. Their average will also be high. But if you look at their strike rate, it's going to be very bad because it's a test cricket. You don't have to finish everything in one day. So you have to play for 5 days, right? So ultimately their strike rate is going to be very low. So when Rahane or Pujara or batsmen like them are going to maximize their efficiency, they will assign very low weightage for an output like strike rate. Whereas they will give more preference to number of matches, number of runs, average, or number of deliveries faced. These could be other outputs, which they will try to utilize. Whereas if you bring a player like Sehwag, right, his strike rate is going to be very high. So he will give more weightage to strike rate than number of deliveries faced. He has no patience. When he comes, it's going to be hit out or get out. He will focus more on strike rate and he will focus less on number of deliveries faced. So that's why in your particular problem, that particular DMU has assigned 0 weightage for a feature like strike rate. Is that fine?
I understood this part. So now this is a selection part somewhere. I mean, if is this a selection part? I mean, on the basis of these, I will
No. I mean, many people are doing it. It's very wrong. So here, if you say your novel contribution is the features that you select as inputs and outputs, that is your novel contribution. Whenever you're working on something like this, you have to be completely unbiased. You should not select features that will maximize efficiency of a particular DMU and that will make another DMU inefficient. So it has to be an exhaustive set of inputs and outputs. There should be no bias in selecting features. That is very, very important when you do something like DEA. Even you can write a research paper out of DEA. I know many of my friends who have done this. Just use DEA as a tool. But the unique contribution comes from identifying unique set of inputs and outputs. So it has to be exhaustive and unbiased. So you cannot ignore strike rate for Pujara and Rahane, and you cannot ignore something like number of deliveries faced by for Sheva. It has to be completely unbiased. But each person has the flexibility to give weightage for set of features. Is that fine?
also give me a minute because I am able to relate this example with that. So,
Yeah.
I mean,
We can also have this discussion next week.
no, I will forget. I will forget this everything. I mean, whatever I have doubts now, because I'm doing right now the 9th week, so I have a doubt.
Sure.
Still, I wrote them, so I will able to ask them in the next session.
Sure.
One last question other than this LP, I'm doing it with the use of this Excel tool. I maybe find it with a Python also. But how do you do it with an analytical method, with the pen and pencil, solving part especially? So I'm not able to roam the YouTube yet, but do you give me an idea how to do it with the pen and pencil?
If you remember in the last session, Malolan mentioned a key term called simplex method, graphical method, and so on. So here you need to have a primer on operations research course. So you can request your management for something on operations research, fundamentals of operations research, or first course into operations research, and so on.
So it's like making common areas, something like that. Common area to all of the equations.
No. So what I'm telling is, do not focus much on them because we won't be asking you from the exam point of view. We are not going to make you solve LP problems.
No, it's just a curiosity that arises.
For that, you need to do a full-fledged course on operations research.
Understood. It's like above my head, no problem.
That is the first step in operations. Once you start OR course, the first thing that you will learn is how to formulate an LP problem. What is an LP? Why is it LP? What are the components of it? How to formulate it? Then comes the pen and paper method of solving. That is where all of these algorithms, simplex algorithm. Then you have this thing. First would be the graphical method. Then you will have the simplex method where variables increases, and so on and so forth. That will be coming in, but that is not in scope for us. But if you want to learn it, any operations research textbook, the first chapter would be on linear programming, and in that, the first thing that they will talk about would be graphical method, then simplex algorithm. So you can take that as a starting point if you want to learn on your own, but it's not in scope for our course.
Oh yes, there is something on Karish Kuntakar condition. yes, definitely it is. It will come in the OR course.
Oh, KKT, yeah, KKT is okay.
Don't ask me what is KKT. I don't remember. No, I cannot give you a proper explanation on KKT now.
Yeah.
Yes,
KKT
sir. Even I forgot, but we have read this thing in MLF. So yeah, that's right.
Oh, nice.
Fair enough. In optimization, non-linear optimization, it comes.
Yes.
KKT, cache control.
Okay. So we have course on optimization as well, right?
No.
I think you can request. You can request your manager.
You can make a request, definitely.
Yeah, because
make a request to the
it seems interesting.
Yeah, definitely interesting.
There are a lot of opportunities in this area as well. In industry, you are getting a lot of data scientists who are focusing on NLP, computer vision, forecasting, and so on. but people with OR background is very, very less. There is demand for OR scientists. You can definitely make a good career in OR.
And in case
OR,
if any of you
operational
are,
research.
yeah,
Yes,
OR.
yes.
And in case if any of you are wondering, since you told it's coming in MLT, right?
Yeah.
OR forms the basis on which all of your models are built. Because you find for example, in logistic regression, you are optimizing for the maximum likelihood, right? So that is the underlying background of it is OR. So that is where OR comes as an important thing. It runs in the background without anyone realizing that is what is being applied over there.
Okay.
Optimization is in the background here. But yeah, then for deviating from discussion here. So let's stop here.
All right, if there are no more DA questions, we can close off this week. And next week, we can have a small discussion on conjoint analysis. And then we'll also take up your doubts.
Please see the videos and come, all right? A request from us. Because our live sessions are not meant to teach you. It is more of a discussion on what has been taught. So that is how we have structured all of our live sessions now. So please see the videos and then come.
Sure. Yeah, we will. Both weeks video, right? 10 and 11.
Yeah.
both.
10 and
Yes.
11.
Yeah.
Malolan, we are closing on time this week. It's an achievement.
For me, with you, everything is always an achievement, man.
Thank you.
Thank you, sir. Good.
Thank you.
Thank you.
It was
Thank you.
a good
Bye.
session.
Thank you, sir.